So far, when we've considered radical equations that contained two radicals, those were the only terms. So for example, we've considered equations like square root 12x minus 23 is 2 times square root 2x minus 4, in which, if we squared both sides, we could eliminate both radicals at the same time. But if we have an additional term, then squaring both sides is not able to eliminate both radicals. It only eliminates one. Now, arranged this way, if I do square both sides, I will at least eliminate one of the radicals. Right, on the left here I have a squared and a square root, and those cancel out. But on the right, well, I'll square the first term, and then I'll have 2 times the product of the terms, plus that last term squared. And when I work that out, I still have a radical. However, I have improved matters. After squaring both sides, I've gone from having 2 radicals to having 1, and that's the best I can do in this case. But if I met this equation in the wild, I would know what to do. So if I met this equation in the wild, I would isolate the radical and then square both sides again. So where does that take us? So we have 12x minus 23 equals 8x minus 16 plus 1 plus 4 root 2x minus 4. Right, I just put the non-radical terms together at the beginning. 12x minus 23 is 8x minus 15 plus 4 root 2x minus 4. So I'll subtract the 8x on both sides, add the 15 on both sides. 4x minus 8 is 4 times root 2x minus 4. Noticing that 4 is a factor of the left-hand side, I can go ahead and divide both sides by 4 at this stage. So I get x minus 2 is root 2x minus 4. Okay, that's quite a bit better. Now I can again square both sides. On the left I get x squared minus 4x plus 4. On the right I get 2x minus 4. And now I have a quadratic equation, but I know how to solve that. I'll subtract 2x on both sides, add 4 on both sides. Since these numbers are small, I'm going to give factoring a try. And I notice that negative 2 times negative 4 is positive 8. Negative 2 plus negative 4 is negative 6. And so I can factor this as x minus 2, x minus 4. And thus my solutions are x equals 2 or x equals 4. If you used the quadratic formula, that would also be correct. We would get the same solutions. Now, remembering that squaring both sides has the potential to introduce extraneous solutions, we take these numbers back and check them in the original equation. Recall our original equation was square root of 12x minus 23 is equal to twice the square root of 2x minus 4 plus 1. So plugging in x equals 2, our left-hand side we get square root 12 times 2 minus 23. So that's square root 24 minus 23. That's square root 1 is 1. For the right-hand side, we have twice the square root of 2 times 2 minus 4 equals plus 1. equals twice the square root of 4 minus 4 plus 1, which is twice the square root of 0 plus 1. Square root of 0 is just 0. 2 times 0 is still 0, so that's just 1. We see that those are the same, so x equals 2 is really a solution. Plugging in x equals 4, we have square root 12 times 4 minus 23. That'll be the square root 48 minus 23. That's square root 25. Square root 25 is 5. For the right-hand side, we have 2 times the square root 2 times 4 minus 4 plus 1. So that's 2 times the square root 8 minus 4 plus 1. 2 times the square root of 4 plus 1. Square root of 4 is 2. 2 times 2 is 4 plus 1 is 5. Again, those are the same. X equals 4 is also a legitimate solution there. So in this case, there were no extraneous solutions. We have both x equals 2 and x equals 4 as solutions to our original equation. So the way that we solve these, if there are two radicals and other terms, is just the same as the way that we've done this before. We just have to be more careful. All right, what's the process? We'll start by isolating one of the radicals. Once we've done that, whichever radical we isolated, we'll take an appropriate power on both sides to eliminate it. Now, this can get messy if we need to take a power higher than 2. And it can get very messy if the indexes on our radicals are different. For now, we're only going to deal with 2 square roots in the type of problem where we end up with 2 radicals and other terms. We could use the same process for any power. We could use the same process with different indexes on the roots. But the results would get really messy, and we don't want to deal with that right now. Okay, so we isolated one of the radicals. We took an appropriate power of both sides. Then we simplify. If we're lucky, if we didn't have extra terms, we'll get rid of both radicals at this point. If not, well, then we should be down to 1 radical. If we still have a radical, we isolate that and eliminate it, as we've done before. And now we have a polynomial equation, and we just solve it normally. So I'm going to show you another example, and then I'm going to give you one to try. So suppose we want to solve this equation. We want to start by isolating one of the radicals. So looking at this equation, I'm going to choose one of my radicals to get rid of first. Since I have subtraction here, I think it's easiest to choose just to add the second one to both sides. So I'll have 5x plus 10 square root equals x plus square root negative x squared plus x plus 10. Okay. So now I have to square both sides to eliminate that first radical. And noticing that there are 2 terms on the right, I'm not going to be lucky enough to eliminate the second radical as well. What do I have here? On the left, I'll just have 5x plus 10. On the right, I'll have x squared plus 2 times x times that second term, negative x squared plus x plus 10, plus that second term squared. then the squared and the square root cancel out. So 5x plus 10 equals x squared plus 2x times this square root plus negative x plus squared plus x plus 10. I notice something nice happens when I combine my like terms. Right. I've got an x squared and a negative x squared, and those cancel out. So I have 5x plus 10 is 2x times this square root plus x plus 10. Okay, it gets even better. Right? Now I want to isolate this square root. I'll subtract x and subtract 10 on both sides. And I just have 4x equals 2x times this whole square root. I can divide both sides by 2 here, but I want to avoid dividing both sides by a variable if I can possibly help it, because that can cause other problems. So I'll say 2x is x times the square root of all that stuff. And now I'm ready to square both sides again. On the left, I'll have 4x squared. On the right, so I have x squared times the square root and the squared cancel out. Okay, and now I have a polynomial equation. I solve this normally, so I need to get 0 on one side, get everything multiplied out, and then refactor. So I'll have 4x squared is negative x to the 4th plus x to the 3rd plus 10x squared. We'll subtract 4x squared on both sides. So I'll have 0 equals negative x to the 4th plus x to the 3rd plus 6x squared. Okay, well, I can factor out an x squared. I can do even better than that. I can factor out a negative x squared. And then this quadratic factor, well, these numbers are quite small, so I'm going to try to factor that too. And I notice that negative 3 times positive 2 is negative 6. And negative 3 plus positive 2 is negative 1. So I'll get 0 equals negative x squared times x minus 3 times x plus 2. That's going to give me solutions where x equals 0, where x minus 3 equals 0, or where x plus 2 equals 0. So x equals 0, x equals 3, x equals negative 2. Okay. Again, we need to check for extraneous solutions in the original equation. When x is 0, this first one works out to 10, minus when x is 0, the second one works out to 10, equals 0. Root 10 minus root 10 equals 0? It sure does. When x is 3, we have root 5 times 3 is 15 plus 10 is 25. And then 3 squared is 9, make it negative. Negative 9 plus 3 is negative 6 plus 10 is 4. So root 4. We want to know, does that equal 3? So root 25 is 5. Root 4 is 2. 5 minus 2 really does equal 3. Finally, when x is negative 2, well, let's see. 5 times negative 2 is negative 10 plus 10 is 0. Negative 2 squared is 4. Make it negative, that's negative 4. Minus 2 is negative 6. Plus 10, we have root 4. And we want to see, does that equal negative 2? So root 0 is 0. Root 4 is 2. 0 minus 2, that sure is negative 2. So again, all three are solutions, and no extraneous solutions appear. Okay, now I'm going to give you one of these to try. So solve the equation square root 7x plus 8 minus square root x plus 5 equals 3. Pause the video and try this now. Okay, so again, we want to isolate one of our radicals first. So I think it's going to be easiest to isolate this one first. Though if you chose to isolate the other one, you'll end up in the same place. So I'll add square root x plus 5 to both sides. And now I'm going to square both sides. And on the left, the square root and the square cancel out. On the right, we'll have 3 squared is 9, plus 2 times 3 is 6, root x plus 5, plus root x plus 5 squared. So 7x plus 8 equals 9 plus 6 root x plus 5 plus x plus 5. Okay, so I didn't eliminate both radicals, but I did eliminate one. Now I want to simplify. 7x plus 8 is 6 root x plus 5 plus x plus 14. Now I want to isolate the second radical. I'll subtract x on both sides, subtract 14 on both sides. I've got 6x minus 6 equals 6 times root x plus 5. It's pretty easy to see that 6 is a factor of both terms on the left, so I'm going to go ahead and divide both sides by 6. X minus 1 equals root x plus 5. Now I've isolated my second radical. I get to square both sides. X squared minus 2x plus 1 equals, the square root and the squared cancel out, x plus 5. Okay, now I have a polynomial equation. I want to get 0 on one side, so I'll subtract x, subtract 5, x squared minus 3x minus 4 equals 0. Again, these numbers are fairly small, so I'm going to try factoring. I notice that negative 4 times 1 equals negative 4. Negative 4 plus 1 equals negative 3. So my factors are going to be x minus 4, x plus 1. So my solutions are x equals 4 or x equals negative 1. I'm not finished though, because I still need to check for extraneous solutions in my original equation. So recall my original equation was square root 7x plus 8 minus square root x plus 5 equals 3. So when x equals 4, I have 7 times 4 is 28, plus 8 is 36. 4 plus 5 is 9, so that'll be 6 minus 3 does indeed equal 3. When x is negative 1, I have, let's see, negative 7 plus 8, so square root 1, minus negative 1 plus 5 is 4, so that's 1 minus 2, which is not 3. Right? So negative 1 is extraneous. My only true solution is x equals 4. Now I want you to notice something about this process. Each of these problems took us a fair amount of time to solve and used up about half a page. These problems are just that way. This is one of those things that just takes some time and takes some space. You should expect, if you see an equation with two radicals and other terms, that it's going to take you some time to solve it.